Good day, grade 12. If you're watching this video, then you've probably gotten to functions we're all studying. And in this video, I'm going to work through the June 2022 question number 4, which was based on functions. Now, before we continue, remember that functions and graphs count approximately 35 marks in your final paper and in your prelims. And some of those questions you can definitely get a few marks from. As you can see in the next question that we do is, in the vast majority, it's testing your knowledge to see, do you know the characteristics of the equation of the hyperbola, and do you know what everything means? So there's not too much of interpretation questions, and it's more of just, do you understand the formula, and do you know your equations and all the properties? Now, for instance, if they start with the first question, they give you f of x equals to 8 over x minus 2 plus 2. And this, remember, whenever we see a division with x, when it comes to functions, we have to think hyperbola. No other function will divide with the variable. Now, they ask you in the first question, 4.1, write down the domain of f. Now, the domain is essentially all the x values for which the function is continuous. Now, that's the fancy wording. In other words, this is all the x values for which the function exists, for which there will be a y value. Now, for the hyperbola, the domain will always be x is an element of all the real numbers except for where x is equal to the negative value of p, or the opposite sign of p. Now remember, in your general equation for hyperbola, it is always some constant divided by x plus p plus q, where q shifts your graph up or down depending on the sign, and then p is the thing that adds to the x in the denominator in the fraction, and if it is positive, it moves the graph to the negative side, and if it's negative, it moves it to the positive side. Now, in this case, we can then say for 4.1, where we have to write down the domain, x is an element of all the real numbers except where x will be equal to, well, p is already negative, so the opposite sign would just be 2. So x is an element of all the real numbers except for where x is equal to 2. So that was easy 2 marks, and I have faith that you will be able to do this. Now remember, again, this rule always applies for the hyperbola and the domain. Now, question number 4.2 then asks you to calculate the y-intercept of this function. Now remember, for the y-intercept of any function, your x value at that point will always be 0. So when they ask you for the y-intercept, you make x 0 and you substitute it into the formula, and from there we will be able to calculate that y will be minus 4 plus 2, so the x-intercept will be where y is equal to minus 2. Now remember, the y-intercept is essentially where it will cut through the y-axis. So the coordinate would be 0, minus 2. Okay, so that would have been another mark. Now the next question asks you to calculate the x-intercept of f. Now remember, at the x-intercept of any graph or function, your y value will always be equal to 0. Therefore, we can now equal our y value, which would just be the f of x part, to 0. So 0 equals to 8 over x minus 2 plus 2. And now we need to solve for x. So in this case, I would start by, the simplest way to start would be to throw the plus 2 over, and it becomes negative 2. So negative 2 equals to 8 over x minus 2. And then from there we need to get the x minus 2 out of the denominator. So we multiply with x minus 2 on both sides. So then we are left with minus 2 times x minus 2 is equal to 8. Watch me now. Equals to 8. From there is a few methods we can use to continue, but for simplicity's sake, I'm going to continue by multiplying the negative 2 in to the bracket. So then it's negative 2x plus 4 is equal to 8. And now this is a linear equation, so I can just solve for x like I would normally do. So I throw the 4 over, so minus 2x equals to 8 minus 4. Therefore minus 2x equals to 4. And I need to solve for x, so I divide on both sides with minus 2, so x is equal to minus 2. So my x-intercept, this is where my function will cut through the x-axis, would be at minus 2, 0. Okay, then the next question now asks you to sketch the graph of f and clearly indicate the coordinates of the x and y intercepts as well as the asymptotes. So few things we need to determine first before we can sketch is first of all the shape of the graph. Now we already know it's hyperbola like established, but we have to determine the shape as well. Now in this case the 8 will determine this shape, and since the 8 is larger than 0, meaning our a value is larger than 0, we know that our graph will be somewhere within the first quadrant and the third quadrant approximately. Then we also already know the x-intercept from the previous question, so that will be where at minus 2, 0, and my y-intercept will be equal to 0 minus 2, also established from question 4.2. Then for our asymptotes, now the hyperbola always has 2, and the 1 is where y is equal to q, so therefore we will have a asymptote where y is equal to 2, and the other one is where x is equal to minus p, and in this case it will be where x is equal to 2. From there we now have all the information we need to sketch our hyperbola. So we quickly roughly sketch our Cartesian plane. We always start by sketching on our asymptotes. So our asymptote will be where y is equal to 2 and x is equal to 2. Oh goodness. Okay, and where x is equal to 2, and then we plot our important points, such in this case it will be our x and our y intercepts. So my x-intercept will be where x is 2 minus 2, and my y-intercept where y is y is minus 2, and then we know our shape should be somewhere within this part over here and that part over there. Now it's important that your hyperbola should get closer to your asymptotes, but it should never touch, and that would be your hyperbola. The next question, 4.5, asks you if y is equal to minus x plus k is an equation of the line of symmetry of f, determine the value of k. Now it is important to note that on your hyperbola you have your two asymptotes. Now the point where they intersect, so in this case it was at 2, 2. Both your axes of symmetry, both the one with the positive gradient and the negative gradient, always pass through that point. So when they tell you that if y equals to minus x plus k is an equation of the line of symmetry of f, we already know that it's going to pass through this point over there. So we can say, thus, we can start by substituting, take 2 into y is equal to minus x plus k, and we can now substitute these points in so we can solve for k. So 2 minus 2 plus k, the minus 2 gets thrown over, so 2 plus 2 is 4, and we have our k value. So just as a quick recap, we know that all our axes of symmetry for the hyperbola, both options we have, always pass through this point where the asymptotes intersect. Therefore, in this case, we could substitute that point into the equation they gave us to solve for k. Now, on another note as well, ladies and gents, for the axis of symmetry for hyperbola, the gradient is always either 1 or minus 1. Your gradient for your axis of symmetry of the hyperbola always has a gradient of 1 or minus 1. And now finally we can get to the last question, in which it states, determine the equation of the graph which is formed if f is shifted 3 units to the right and then reflected across the y-axis. Now if we reflect something around the x-axis, then all that means is your y values change signs. So if something was at coordinate 2, 3 and it shifted around the x-axis, then the coordinate will become 2 minus 3. So your y values just change signs. So that means if we reflect f of x across or around the x-axis, let's call the new function we're going to work with g of x, then it will be negative f of x. That's for the y reflection. So if we want to reflect f of x around the x-axis, we need to make all the values from f of x, the y values, change signs. But then also that's what's important is that in this case we want to shift the graph 3 units to the right, meaning where we see x minus 2, we should subtract another 3 so that the function gets shifted to the right. So that is essentially the rule that we're going to have to follow to reflect f of x around the x-axis. We're going to have to make the entire f of x negative, and then at the x minus 2 we are going to have to subtract another 3. Therefore the new function will be at negative 8 over x minus 3 minus 2 plus 2, and then simplified minus the bracket 8 over x minus 5 plus 2. We multiply the negative in, so negative 8 over x minus 5 minus 2, and that would be your reflection. So as a quick recap, because it's reflecting around the x-axis, all my values for f of x need to become negative, the y values, and since it's being shifted to the right, I need to subtract another 3 from the x value. And with that, ladies and gents, that was question 4 from your June 2022 exam paper. On that note, remember the bumblebee does not do something the bumblebee does something impossible every day.